The half-life of phosphorus 32 is about 14 days. There are 6.6 grams present initially. Express the amount of phosphorus 32 remaining as a function of time t. When will there be 1 gram remaining? Since this is a half-life model, we can just simply use the half-life equation. We state that the amount at any time t is the initial amount times 2 to the negative t over the half-life t. In this case, A of t is 6.6, 6.6 being the initial amount, times 2 to the power negative t, which is the variable of the function time, over the time of the half-life, which is 14. Notice that this is the same as writing 6.6 times 1/2 to the power t over 14, 1/2 for half-life. If we want to express this equation in the natural exponential form, a e to the kt, in this case this is dk, so it should be negative kt, then a is 6.6, e is e, negative k is the parameter, and t is t. What this means is that when we compare these two equations, we must have 1/2 to the 1 over 14 power needs to be the same at e to the negative k. We then ln both sides of this equation to get ln of 1/2 of 1 over 14 equals ln of e to the negative k. Negative k is therefore negative 0.0495. So k is 0.0495. And so in the natural exponential form, this is 6.6 e to the negative, k is 0.0495. T is still in the exponent. Both formulas give us the same result. The formula with 2 to the negative t over 14 or 1/2 t over 14 is more accurate because we actually rounded k. Next, when will there be 1 gram remaining? This equation gives us the amount at any time t. T in this case is the number of days. When is the question of time. So we're looking for the time, the number of days, when the amount is 1 gram. The equation or the model is 6.6 times 1/2 to the t over 14. We don't know what t is, but we want to find the t so that the amount is 1. To find t, we first divide by both sides of the equation by 6.6, so the left-hand side is 1/2 t over 14, and the right-hand side is 1 over 6.6. We then ln both sides of the equation to get the left-hand side, ln of 1/2 to the t over 14 equals ln of 1 over 6.6. We bring t over 14 to the front of ln. We get t over 14 times ln of 1/2 equals ln of 1 over 6.6. Isolate t, we get 14 divided by ln of 1/2 times ln of 1 over 6.6. To isolate t in this case, we would multiply 14 to both sides of the equation and divide by ln of 1/2. Input this into a calculator, we will get approximately 38. This is the number of days. It will take about 38 days for phosphorus 32 with a half-life of 14 to end up with 1 gram remains.